In this video, I'm going to show you how to use the GPIO interrupt with the Nucleo board. So as usual, I'm going to turn on the, I'm going to open the STMQ-MX. Access the board selector. Under the Nucleo 64, I'll select my board, which is the L053R8. Double click on this and initialize all peripherals with the default mode. Click yes. So without the high-speed crystal, these two pins can be set to reset state. Okay, I'm going to use the button on the Nucleo board, which is connected to the PC13 blue push button, and once I press the button, it's going to turn on the LED, LD2, the green LED, which is connected to PA5. It takes some time for it to focus. Yeah, the autofocus is not doing well. Okay, I can see this is the blue button. So when I press the blue button, it's going to turn on the LED over here for about 1 second. Turn off. Turn on again and turn off. So under the clock, I'm going to set to 60 MHz. Back to the pin configuration. Under the system call, GPIO. So I'm going to go to the NVIC tab and turn on the enable the interrupt. So let's call this a test GPIO. External interrupt. Let's call it interrupt. EMDK arm, which is we are using the Cal microvision. So I'm going to open the main.c. And to access interrupt, we have to open the STM32IOXX_IT, which is the interrupt C files. And if you go bottom, you can see that external interrupt 14 to 15 IRQ handler, which has been generated for us. And double click on this. Okay, we have to compile one time. Make sure there's no error. Okay, right click on this and go to definition, and we'll see that because this IRQ handler will clear the interrupt flag and call this external interrupt callback. So go to definition of this, and we see that actually it's not doing anything. So we're going to put something into the callback. It's a weak function, so we can override in the main.c. So I'll put this in the user code begin 4. So what I will do is that I'm going to turn, once it's pressed, the B1 button, the blue button, and I will turn on the LD3, which is a green LED, from here. So the button is called B1 and the green LED is called the LD2. So first we have to check whether the pin is correctly activated. So the pin is called the B1 pin. And we are going to turn on the LD2 green LED. So we see B1 underscore port, B1 pin, and we're going to set the GPIO pin state. Set. And we put a delay of say 1 second. So it's 1000 milliseconds. And we'll turn it off. So reset. So what this statement is doing is you write the pin, the B1. Okay, we should put the LD2, 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 which is a green LED. Okay, let's compile, make sure there's no error. Go to the debug, project option, debug settings, and the connect should be put with pre-reset. Okay, I don't need this window, and I can close this window as well. Okay, so I start the program. Okay, so you can see from here, this is my board, and once I press the blue button, what it will do is it will turn on the green LED, and after 1 second it will turn it off. Okay, notice that it doesn't turn off. Okay, let's go back to the code again. In the code, let's close the debug. Okay, over here, what happens is that the delay, the Hall delay is using the SysTick, which is internet interrupt, which has the priority of 0. Okay, 0 means have a higher priority, and the larger number it goes means the lower priority. So this Hall delay is assigned with the priority 0, and if you look at the QMX under the system view, GPIO, let's look at okay, under the NVIC, external interrupt 4 to 15 interrupts, the priority is given as 0, so they are having the same priority level. So you can find it in the you can find in the datasheet that when an interrupt request with a lower or equal priority is raised during execution of an interrupt handler, it becomes pending. So once the interrupt handler has finished, the pending interrupt is skipped and control is transferred directly to the new exception handler to decrease the interrupt latency. So which means that it will skip. If the interrupt within the interrupt has the same level of the interrupt, it will skip the pending one. The delay interrupt will pend, and after the finish of the interrupt, it will not go back to execute the interrupt anymore. Okay, so there are two ways that we can do. One way is, instead of putting this on off of the LED here, we can raise a flag here. So in your main code, the while loop, we can do a if else loop, if else to check the flag. So if the flag is raised, then turn on the LED. If not, then it will turn off the LED. Okay. Another way is we can put the interrupt of the GPIO to a lower priority, so that when it comes to the interrupt, it sees that the delay has a higher priority and it will execute the delay as well. Okay, so over here I change my interrupt, pin interrupt to, let's say, level 3. Level 3 means lower priority. And now we generate the code. Compile again, and we'll go to the debug. Okay, we'll run the program and take a look at the actual board. Okay, so now if I press the blue button, the green LED LED2 will turn on for 1 second and turn off. Okay, so press again, turn on, 1 second and turn off. Okay, so that's the end of this video.